Sorry, Annika, I forgot to hit the record button. So these two guys are equal. And two things are equal, what can you do?
Put them equal to each other.
Except them equal to each other. They're both equal D, they have to equal each other. We know that property. We do. So let me shrink this out and then we'll do a little math. So T plus 8 times 2 must equal T times 20. That's not a hard problem to solve, is it? Really not. Now, to the left, you got 2T plus 16. That's 20T. Let's just subtract 2T and divide by whatever's left. So if I subtract 16, sorry, if I subtract 2T, I'll have 18T. It's kind of interesting that T is 16/18. Something seems wrong about this. Oh no, this is Tony's time, right? That's the issue. That's Tony's time. Way less than an hour. It doesn't take Tony long at all to catch up to somebody who's running 2 miles per hour, does it? Remember, T is Tony's time. So the actual question is, what is the distance they both covered? We didn't answer that. We found the time. The time is 8/9 of an hour. All right. The question is distance. Where do we put that 8/9 of an hour? That's right there. Distance is 8/9 of 20, which I'm not going to do that by hand. Pull up a calculator and do that one. Because this is kind of real world. Kind of not. I seriously doubt the world's high. There is such a thing as the world's highest runner. Well, depending on the drug, usually it makes a person rather lazy. Most of the kids that I went to high school with that stayed potheads are really lazy individuals. Really not. It's about 17.8 miles per hour. Well, there's always exceptions to that rule, but just let it kind of work out for that group. I don't know. Look around. You guys know your friends. Is that still true? Just the way that is. Now, the other drug, meth, that's a whole different thing. Those people are hyper and up for days. All right, so I hope that helped with the uniform distance. Did it do you any better than yesterday? Maybe? I don't know. A little bit? I guess you won't know till you try it. All right, so that was the original one. Now, these are always fun. A motorboat heads upstream at a distance of 24 miles on a river whose current is running at 3 miles per hour. The trip up and back takes 6 hours. Assuming the motorboat maintained a constant speed relative to the water, what was its speed? Is there anybody in here who hasn't been like on a boat on a river? Well, your boat will say you're going, I don't know if it's, some of them are in miles per hour, some are not, but it'll say you're going 20. But if the river is flowing at a current of 5, what are you actually in reality going compared to land? 25. Now, if you're going upstream and the river's pushing 5, you got to subtract that 5 from your speed because it's about relative to land. And that's what this question is. It's relative to land. So let's see what we know. A motorboat heads upstream a distance of 24 miles. So the distance upstream, which I'll call D subscript U, is 24. And we're going to go upstream and back, right? The distance downstream is the same thing, isn't it? So I'll call that d subscript d. This is nice. We have two things that are equal to each other. That means we're going to write two equations, and guess what we'll get to do? Set them equal to each other. That's how this section works. You just have to figure out what you're going to do. Now, we have a formula we can use. We're using the formula distance equals speed times time. Let's talk about upstream. The distance is 24, and it has to equal something. It has to equal something. Let's see. Oh, wow, they even gave you a pretty little picture, didn't they? They have rate minus 3 miles per hour and rate plus 3 miles per hour. I don't know if you noticed this, but when you're going upstream, your speed is r minus 3, where r stands for what? Rate of speed. Rate of speed. Time's the time. I don't know the time. I know that the trip back and forth takes 6 hours, but if one way is faster than the other, are they both the same times? So I'm going to have to come back to that, okay? Times some time. Downstream is 24 equals rate plus 3 times the time. Huh? No, that needs to be talked about. Huh? 6 hours, but that's trip there and back, isn't it? I'm going to change these variables here. I'm going to call that the time upstream. I'm going to call this the time downstream. I can't just say t because they are not the same thing. They are different times, kids. You can't just say that you spent 3 hours going both ways because that doesn't make a lick of sense if one direction's faster than the other. What you know is that the time spent upstream plus the time spent downstream must equal what? Must equal 6. Those are two different times. We need to make sure that we grasp that. They're different times. Now, if I was just to take these two equations right here and set them equal, because they're both equal to 24, right? If I was to write down on a piece of paper that r minus 3 times the time spent upstream equals r plus 3 times the time spent downstream, could I do anything with that equation? It's got too many variables. It's got 3 variables. The r's aren't really a problem because those are going to cancel each other out. But it's got 3 variables. That is the whole point of this equation right here. Which one do you want to solve it for? Time upstream or time downstream? Pick one. Why not? Kelly said solve for time downstream. I'm okay with that. How do you solve for the time downstream? 6 minus time upstream. And you're going to want to kind of label your variables a little bit, kids, because if you just write them as t's, like you're going to think you can pull off some algebra that doesn't really exist in that problem. They are different times. They need to be called something different. That's why I'm using these subscripts. Differentiate the different things. So everywhere I see a TD, what can I replace it with? This equation might be doable. R minus 3 times the time upstream must equal R plus 3. And time downstream has now got two things, 6 minus time upstream. Now, before I continue on with the easy part of this question, anybody got anything you need to talk about? All right. Well, what do you guys want to do? It's ready to be solved. I know you're worried it's got R's and T's, but that's going to work its way out. Yeah, they will cancel eventually, so don't be too scared of it. They're probably going to kick in. I see a foil on the right. What do you see on the left? Distributed. Properties you're aware of. So R times TU is literally RTU minus 3 TUs. Here you're going to have to FOIL. 6R minus RTU plus 18, right? Minus 3 TU. I probably should have kept typing for your sakes. Looks to me like the RTU didn't cancel, did it?
Yeah.
RTU did not cancel, did it? Oh man, that really sucks. Well, let's see what happens. Maybe we can still get around this thing. Let's see here. If we shift this guy over, we'll have 2 RTU. Those guys canceled. That was kind of nice. You got a 5R plus an 18. Oh, I don't know where I got that from. I was looking at that 6R minus RTU, wasn't I? That's still 6, isn't it? That's me. Oh, bummer. This is a huge bummer. Why is this thing a bummer now? How many variables do we still have? I really thought those R's would cancel themselves out, but they did not. Oh, that stinks. That really, really stinks. So we need to do something differently. This happens. Sorry, it happens. Joke's on you guys, though. I did all that for nothing. And I knew it. I thought at the end, though, the R's might cancel, but they didn't. What was our original uniform motion equation? Speed is distance over time. I think that was it. Now, we actually had 2 speeds here. One of them was R plus 3 and one of them was R minus 3, wasn't it? All right, so we're going to have R plus 3 equal to 24 because we do travel 24 miles over some time. We'll call that time upstream. The other one was R minus 3 equal to 24 over some time downstream. This is better. I think it's better. Now, I still want to talk about that one equation that we had written earlier, because you still need that piece. We know about the time upstream plus the time downstream. That was 6, wasn't it? You guys still want to solve for the way we did last time? I think it was time upstream. No issue with that. Time upstream is 6 minus time downstream. Now what we can do is we can replace this time upstream. I think we actually did it the other way around last time, didn't we? Whatever. We can take this time upstream and we can replace it with 6 minus time downstream. We're getting close. Are those two equations equal? Does 24 over 6 minus the time downstream equal the same thing as 24 over the time downstream? No, one of them's equal to r plus 3 and the other one's equal to what? So modify it, make them equal. What should we take away from the top equation? I'll give you a hint. We want them both to equal r. Take away 3. What do you add to the bottom equation? 3. Minus 3 plus 3. I know, it's fun stuff. That floor is so much more exciting. Maybe we should have had the world's highest self-boat driver, and on the way back, he became the world's roughest boat driver. I don't know. Are they finally equal the same thing? Two things equal the same thing. What do you do? Put them equal to each other. This is going to be our correct setup on this one. I think those two things, which got really messed up when I did that movie, didn't they? But 24 over 6 minus the time downstream must equal 24. I did, didn't I? Thank you. Minus 3. Over the time downstream plus 3. So there's your equation. This is going to give us the time downstream, because that's the only variable in the thing. How do you want to solve that thing? Fraction multiplied by LCD. Your denominators are time downstream, 6 minus time downstream. What's your LCD? Six minus time downstream, but that's not it. Times time downstream. That's your LCD, kids. Because both those denominators enter that one. Both of them. We distribute to the front at 24. What's left? 24 times downstream. You know what a lot of kids forget about is that. That is forgotten about constantly. You can make it a 6 on the other side. Eventually it will be one. How did you distribute that guy? cancels. TD. Oh, TD canceled. And you got that plus 3. Now your book also has an alternate way of doing this problem as well. You might look at that there, but this one, it's up to you. Let's see here, where was I? Ah, 3. That is an ugly looking thing, isn't it? It really is. At this point, I would kind of suggest that you just replace all those TDs with X's. It's really not needed anymore. And the X's will make everything look so much cleaner. It really will. They'll also make it pretty obvious to you what you need to be doing. Because I could see how what we have written in front of us is very scary. So everywhere I see a TD, I'm replacing with an X. Is that near as scary? No, it's a lot prettier looking. You're comfortable with X's, so it ought to be pretty obvious what you need. I guess you need to do the distributive property a couple times, maybe one side this thing and attempt to maybe factor it. If it doesn't factor, we'll have to with the quadratic formula. So we'll do a little cleanup operation here. 24x there. 6 minus x times x is 6x minus x squared. Times a negative 3 is negative 18x. I have a typo too. I did two things at once there, kids. I distributed the x and a negative 3. 24 times 6 minus x is 144 minus 24x. And there's that thing again this time, but this time we've got 18x minus 3x squared. And I did make one mistake on the left. It's right there. That was a 3. Every time you've seen an equation that looks kind of like this, what have you done? Combine like terms, maybe on one side. Okay. Which direction should we shift, left or right? Left. Yeah, shift left. So what's going to be on the left is going to be a 6x squared. We'll have 24x plus another minus 18x, that's 6x. And over here we have a negative 6x. So I think we have plus 12x. And what do we got left? Numbers to work with? Minus 144? 12x should be positive. This piece right here creates a positive 6x. This piece right here creates a negative 6x. Minus 144 equal to 0. I've noticed over the years that when a problem tends to get difficult, the attention span just drops like a rock. There you go. That's what you got. What do you want to do with it? You're also going to follow commandment number 1. What can you pull? Pull out that 6. It can be pulled. And if it can be pulled, it should be pulled. Because it enters all three pieces nicely. Let me times 6 enter 144. There's 24 times. How does x squared minus 2x minus 24 factor? There you go. Why are kids like that? When things get difficult, we just quit paying attention. What are your two rates of speed here? What's it suggesting? Or sorry, what are your two times? This was about times. What's one of your times downstream? -6. Or time downstream is +4. Now I didn't remove that problem. I don't even think that's what they were asking. Were they asking for the rate of speed? No. Which time downstream are we going to keep? We're going to keep the 4, right? It's the only thing that makes sense. Unless you are the world's highest boat driver. You get to keep the other one. Now, we have an equation that talks about rate of speed. It said that r plus 3 is equal to 24 sitting over 6 minus time downstream. In this case, 4. And then all minus, yeah, that's it. I've shrunk everything up so it's hard to see what I was looking at. But I was looking at this equation up here before I modified it by subtracting 3. I was going back and looking at that equation. So you're almost done. 6 minus 4 is 2. 24 divided by 2 is 12. Now subtract 3. 9. That was a good deal of work because I showed you the wrong way first. There's also another technique that involves taking square roots. That's in your book. You can look at it too. There's another technique. Pick whichever one you like. I just wanted to show it to you. All right, last thing you notice is working together to do a job. And these are so easy. So easy. Here's the general setup. It's 1 over, really yellow. Did not know I picked that color out. 1 over rate 1 times some x plus 1 over rate 2 times x must equal 1. We need to talk about what these R1s, R2s, and why the fact that we set it equal to 1 is. Rate 1 is how much of a job can be done by one person in an hour. Rate 2 is how much of a job can be done by the other person in an hour. It's just the rate at which they do. Most of these things are like about painting or mowing a yard. Okay? The reason that we set this thing equal to 1 is because that represents the completion of the entire job. You're supposed to do these in Algebra 1, you're supposed to do them in Algebra 2, and I never do them in Algebra 2. I really should. I have no idea if the adv1 teachers still do them or not. It's really not in our standards anymore. But that's kind of why the setup is on these things. Okay. Now the X here will be the total time two people can do the job together. So what's this about? Oh, they're weeding the garden at 10 a.m. Danny is asked by his father to weed the garden. From past experience, Danny knows it will take him 4 hours working alone. Now, Danny is 4 hours working alone. How much of a job can you do in 1 hour? You can do a fourth of it, right? So rate 1 is 1 over 4. You can do a fourth of that garden in 1 hour, kids. That makes sense to me. His older brother Mike, when it was his turn to do a job, requires 6 hours. How much of the entire garden can he weed in 1 hour? 1/6. Danny has a reservation for 1 p.m. Mike wants to go golfing with Danny. He has a reservation for 1 p.m. He agrees to help Danny, assuming no gain or loss of efficiency. Will they finish if they work together, and can they make the golfing date? Well, all we got to do is plug these things in here. Nothing more. 1 over a quarter times x plus 1 over 6 times x must be 1. Now, you might be tempted to do the LCD method here, but you don't have to. When you divide by a quarter, what are you really multiplying by? 4. When you divide by a sixth, what are you really multiplying by? 6. So the equation here is just 4x plus 6x equals 1. Oh, there's something wrong here. The answer's not going to make any sense, is it? That answer ain't going to make a lick of sense. Did I put the x's in the wrong spot? Hey, forgive me, I haven't done these in a couple of years myself. This is embarrassing. We're back in chapter 1. I done forgot something. I did put x in the wrong spot. I don't even have time to finish it. Just ask me about it tomorrow. I'll fix it then. Go ahead and give your homework a shot.
Are we allocating 3 points to our grade?
Honors course. Honors course.
We just automatically get 3 points?
Yeah. Oh. Rate 1s and rate 2s are right. How did I forget that? It's rate 1 plus rate 2 equals 1 over x. That's what it is. That's the formula. There's the correct formula if you're curious. It's rate 1 plus rate 2 equals 1 over x. Is a quarter plus a sixth. It's 4, 6, 10 24s, 5 12s. Cross multiply.
Yeah, I have a note.
Well, honor Monica, I'm going to go ahead and record this video for you. I screwed up earlier. Sorry you watched that. But rate 1 is still Danny's time to complete a job. Rate 2 is still Mike's time to complete a job. And X is still total time. It's time together. I'll upload here in a little bit this video and the homework and a completed copy of last year's notes, which are probably a little better because I've been off today. Anyways, have a good day. Hope you feel better.